Okay. This isn't, we couldn't use my computer, so I'm just going to have to go completely off the cuff now. Okay, so secure Scuttlebutt and peer-to-peer infrastructure. So what is secure? So secure Scuttlebutt is, to put it in blockchain jargon, it is basically a private permissioned database with proof of stake where there's only one staker per blockchain, except there's like as many blockchains as you like. There's like thousands of blockchains. And each of them can interact by, essentially, they can say that another blockchain, another transaction, another blockchain is an input to a particular transaction. So these blockchains can then get tangled together. So translating that into ordinary computer science, what that means is that it's just signatures and hashes, just the same as like any blockchain project, and BitTorrent, Git, all of those things are basically just signatures and hashes. Secure Scuttlebutt just puts it together in a slightly different way, where it's just append-only chain, so each message points to the previous message and has a signature. And this makes it just a straightforward append-only thing. And this is just, the idea here is just to make the simplest thing that could possibly work. It's just, if you have an append-only thing, you can just replicate it from start to end in order, and then if something drops out, or something fails, then you're still in a valid state, and next time you connect to a pair, you just replicate the things after this. So a few more things in the blockchain jargon. So there's no such thing as a full node in secure Scuttlebutt. There's like the network, and there's as many chains as you like, but you don't have to replicate all of them. In fact, there's no way to know if you really have everything in the universe. Someone could have made something and never connected to anyone, or had their own private network. You just replicate an overlapping, set of feeds that is relevant to you. And then, so this gives you eventual consistency. So things can be from the start to an end, and at some point later you'll receive messages, but then the things are in, and then the funny thing is, like the last time I spoke at a blockchain conference, I also had a technical difficulty similar to this, and also had to ad-lib, but I had better notes. Hang on. Cool. Okay, now I remember what I was going to say at least. Okay. Scuttlebutt is zombie apocalypse ready. Because in the zombie apocalypse, all the national and international infrastructure probably fails because the zombies cut through it, or people are too busy running away from zombies to maintain the stuff, so the internet cables or something stop working, and then you have a network. So this is going to be a big problem for things like Bitcoin and Ethereum, because they depend on one global network, and then that network is going to be partitioned. And getting the new block headers across to like the other threads, well, it might be possible, but it's going to be hard. You're going to need to have some out-of-band way. Whereas Scuttlebutt, it doesn't really matter. So you just have an offline first view of the data that you have, and if someone from your secure compound runs through the danger zone and visits your friends in another thing, then it can just replicate your data to them, and now they have a copy. And then someone else comes back, and then you have their responses to that. It's not fast, but it works. And this stuff is there's some place in the world that basically are ready for the zombie apocalypse, And the idea is if you prepare for the zombie apocalypse, you're basically prepared for everything else because everything is easier than the zombie apocalypse. So that works. And there's another thing, is we have this assumption that the data will have social patterns in it. And by this I mean small world networks, and there'll be a probability, high likelihood that if you say follow this, if you want to get this feed, there'll be another feed that's like a friend of that feed that you're also probably likely to want, and there's like a mutual friends probability that makes things likely. And this is likely to occur in like any kind of data. Like even Bitcoin transactions are transactions between people. So they're also like a kind of social network. When someone uses code in an open source, it uses dependencies, they use it from people that they trust. That's similar to friendship or following people that also has social kind of patterns. You just see these kind of social patterns everywhere. So we can lean on their statistical properties and use that to build peer-to-peer systems. Okay, that slide was a good picture of a network. Yeah, so there's already a bunch of popular applications, things that are built on top of Secure Scuttlebutt that you can use right now. You can use it to talk to other people on this social network thing. You can play chess without spending any Ethereum or however that one worked. You can use Git and store like code and update code, and we do some of the repos for Secure Scuttlebutt over that, and a whole bunch of other stuff. There's also 3 implementations. There's a JavaScript node reference implementation. There's a Go one that's usable. It implements enough of the protocol to replicate with the JavaScript one, and there's a Rust one that's underway as well. So our main idea in our development philosophy is to go for use value. Make something that you can actually use and start off with a thing that can be used like from basically the get-go. So this slide was a graph of the Ethereum price since time. I'm sure you all know what it looks like. The next slide is the Ethereum price on a log scale. Now, if you know to click on the log button, then you're the smart money, because it makes a lot more sense than the other one. First one is like, looks like nothing happens, and then suddenly it goes crazy, and then it's like, oh, it's disappointing. But if you look on a log scale, it's just like steady progress with a few bumps. And it makes a lot more sense. Like, it just looks like it's, oh, this is actually just going somewhere, because all of the thing at the start just looked completely flat. That was actually a lot was happening in there. In fact, if you just zoom into that part, it looks like when you zoom out the whole thing. So that's because it's like an exponential curve. But on the log graph, if it's not perfectly straight, it has bumps. And the bumps don't look very big on the log graph, but actually they're like, in the other graphs, they're like huge spikes. And there's the like steady progress model, but then sometimes people get excited about, oh, this is going to be worth more, so I'll like buy it, and then it makes it just be worth a hell of a lot more. In fact, it makes it be worth too much more, and then it has to come back down again to what the actual progress was. And that's like, there's the actual usefulness of Ethereum, but then there's just the speculation, like the hype, and that's like not useful. And it can be difficult to separate the hype from the actual usefulness. But the usefulness is the thing that's actually important, because this next slide was a slide of the dot-com bubble, And so there isn't a convenient way to just measure, like this is the dot-com bubble, and this was the value of all the companies. The graph for this is actually the NASDAQ composite index, which means that the dot-com bubble even appeared, like it was noticeable on the NASDAQ composite index, meant that the computers had actually entered the real economy of actual companies and made a huge impact on like people that weren't even nerds. Cryptocurrency doesn't even make any difference to this currently. And if you look at the scales, the total value of like crypto is like less than a tenth of what the the .com thing was at its peak. So we still have to look at the Bitcoin price or the Ethereum price. Like everyone in the blockchain world thinks that it will probably go up 10 times once or twice at least. Probably people think more, but I'm being conservative. And then it might start to have an impact, but then the spike and the crash afterwards will actually be like much wider as well. It won't just be like a quick up and down, it takes much longer. And then the question is, what will be left over when it gets out the other side? And the .com, lots of companies went out of business, and the things that stayed were the things that were really useful, such as Amazon and eBay and things like that. And the risk with cryptocurrency is that at some point, basically, if people are holding cryptocurrency because they expect it to be worth more in the future, at some point it just reaches the value that this is what cryptocurrency is going to be worth, and like this is the true value. Well, it's not going to go up anymore, so it's not worth holding it as an investment anymore. It's better to put your money into something that will actually generate a product, but cryptocurrency won't do that. So to make sense, so then you would sell your cryptocurrency. So if you want to actually have that and if they sell it, it will cause it to go down. But if you want it to stay the same, it needs to be useful. So how do you make something that's useful? The lesson that we learned in the Web 1 and the Web 2 was that you start with something useful. Like you build a useful thing as soon as you can, and then you iterate on it. I think this is very different to the approach that cryptocurrency world uses, because they're just like, we're going to build this thing, and it's going to be awesome, and give us tons of money, and then we'll build it. And then some of those things produce something. But I don't hear a lot of stories about things being terribly useful. You can read they wrote books about this in the last decade, lean startup and things like that. So the last part of my talk is a suggestion for something that I think would help Ethereum in particular transition from to another layer of usefulness. So we could take I audited a bunch of Ethereum smart contracts, and I reckon that the prototypical dApp is just a market of some kind. It's some kind of way of exchanging things. And the sort of patterns I saw was that building a smart contract is really hard, because you pretty much have to get it right first time. It's a lot more like hardware than like software. And also, it has all these costs with running it. So if you do anything where you have to iterate over something in the contract, that can be a problem. Like, it might get too big. There's contracts that are just stuck because the gas price to execute the contract on the next step just can't. It's past a limit. So that contract is just frozen until the gas limit gets raised or something like that. This is also a vector for attack and that sort of stuff. Basically, you want to make the contract as simple as possible, absolutely simple. But then there's ways you can facilitate this by just taking information that's about the contract and taking it outside of the contract. So the thing with markets are mostly about exchanging information. So if you want to buy something, you need to find out all of the things about that product or that item or that asset or whatever. And then when you decide it, then you can make a transaction. The transaction is just a small part. Mostly it's about information. Secure Scuttlebutt and things like that, like DAT, etc., are really good at information, at exchanging information. So, but they have a different affordances. Like a smart contract isn't a smart. Yeah, basically you want a very simple smart contract that just decides now this thing belongs to that person and nothing else. then you have all this information about it, like what are the things that are, like what are the contracts that are currently open, what is the information about them, and so on. Let's say you would have, so we want to make this as decentralized as possible. Currently, most of these are just provided by a website, and that's not decentralized. So you'd have something like, you have a full node that keeps track of the contract state, and then replicates that data onto another system, for example, secure Scuttlebutt, and then it just says, this is the information in the contract. This is what I say is the current state of the contract, and then this is then easy to replicate. Now, of course, that's the single point of failure because there's just one. So the solution is you have a bunch of them, and then you follow them all and check that they agree, or they check each other and so on. Now, anyone who is invested in this system needs to, has a natural incentive because they want to see this contract be successful. They have a natural incentive to run the infrastructure for it. So you don't really need to have a special way of paying for these servers because they're not really that big. Like at its height, CryptoKitties was only 14,000 people doing contracts. So it's not like that's like any computer, really the server to handle that is not very expensive at all. So a few people that were highly invested in CryptoKitties could run those independently, and if you were suspicious of them, you could just run one. And then if the end clients had a way to choose which notaries they're exposed to, then it's not completely trustless, but you've given the end user a decision about who they trust, which is the thing that the Web 1 and 2 don't give you, which is just like you can't really choose whether or not you trust Google. Google is like the state, it's like the government. You can't avoid Google. So the way that the notaries could attack this is they could show incorrect data or they could withhold data, but both of these are basically defeated by just the fact that you can choose to use other notaries and other people can easily create notaries. So it's just like, you could do this, but you just won't get away with it. So what's the point of doing that? Yeah, and the notary can have natural incentives because they are for some reason invested in that market. And then the user layer could be like a web interface to these notaries, or it could just be Scuttlebutt, like full pairs that just replicate the notary data. And then it's fully decentralized. So the most important thing is that the one takeaway from this is that cryptocurrency has too much consistency. It needs more eventual consistency because the cost of consistency is always expensive. Eventual consistency is very, very cheap. It was great when the internet, everything on the internet was free. I want that internet to come back. And then a better internet. Okay, thanks everyone.